Next, let's talk about how do we construct an index portfolio. There are actually four methods. Okay, four methods. The first method is the full replication. The second one is, if we don't do the full app replication, let's get some sampling. We call stratified sampling. And another one, instead of using the replication or sampling, we rely on some kind of statistical or economic model to get the optimization to reach the goal of that particular index you construct. And another one is a hybrid, meaning that you mix that together and then try to find out um, the optimal solution, which minimizes your cost. Full replication. All right, what I'm going to do here is to classify, based on when and how to use, and then we look at the strengths um, and some the weakness or limitation of these four different methods. The first one is pretty straightforward. It's replication. For example, suppose we want to mimic S&P 500, then we just replicate entire portfolio, 500 company with a different weight. Now, because you understand that the weighted average, the weight is based on percentage. For example, if there's one of the 500 stock, it's only like 0.1%, 0.0001. Then in order to have that one share, you have to have a 1,000, right? So in other words, you need a lot of capital to really accurate to get the weight. So the larger the number of the stock in your index, that means that you need more capital to do that one. So it costs you a lot. So here the limitation is large capital requirement, substantial cost in terms of initial investment. In order for us to accurately, all right, to mimic that portfolio based on exact weight on that. Therefore, it's very difficult to do it. The other one is that if you want to do the full replication, then you have to make sure that each individual stock inside the index is tradable and also is very liquid. In other words, you're able to replace that quickly. Now, the good thing is this. Once you construct a portfolio, if you have substantial capital, then you don't need to really, all right, back and forth to rebalance that. All right, take it in and take it out because you already have the weight. The only thing at the time is a little adjustment based on rebalance on the stock split or stock dividend. So that is the strength of that. Now, if you look at that, like the Spider SPY, the Diamond DIA, the QQQ, which is the Nasdaq 100 index, these are full replication ETF portfolio. Okay. Now, for other type of the index, if you don't have substantial capital, then we can only take part of that. So we need to sample that, sampling. For example, if you have another index to keep track 5,000 stocks, even it's a Russell 2000. So it's very difficult to replicate the entire portfolio. So what do? We take sample. Now this stratified sampling has the procedure here. The first one is this. Now, if for example we have Russell 2000, there's 2,000 small stocks. So we divided 2,000 small stock hypothetically into multiple dimensional cells. In other words, maybe we can cut into 2,000, cut into 100 cells. So each one we have 20 stocks. Okay, or we can divide it by 10 cell, whatever use depending on your capital size. And the cell in each dimension should have a similar character. Okay, maybe based on different industry or different sector, and you classify multiple cell there. And then you characterize all stock in the index into the appropriate cells. So the 2,000 stock, and you allocate 20 in each one. Sometimes you don't have to be equally, but it just distribute to the 20, say 100 cells. And then you calculate the weight, all right, for each cells, the capital size of all stock in the cells. Now, for example, suppose equally, that you have 20 stocks, but the 20 stock may not have the same, each cell may not have the same capital weight, all right, or capital size. Then you calculate the weights for each cell. Then once you have the cell and you know what are then inside the cell, and then you know the total weight of each cell, then you start picking out the sample from each cell. It could have a random sample, or you can use a representative stocks, right? Depending on if the cell, if you put a random, maybe they are not liquid, or maybe it's not very tradable. So you are using each cell to get the one who is tradable, which is a liquid. You could do that. Or you can just randomly pick the sample. Then you make sure that the weight of stock bought in each cell represent corresponding to cells weights in the index. So you pick it out one. For example, in each 20, and you pick up, say 5 instead of using the 20. All right, so 2,000 divided by 100, that's 20 in each cell, and you pick 5 out of the 20, and then you have the same weight. So each 5 together had one weight, and then you put it together for the entire index. This is called the stratified sampling procedure. Okay. So when do you use? Because if, for example, too many stock in the index, and also many low liquidity like Russell 2000, you should use this approach, and you choose few representative stocks, and right, to replicate an index. And the strength is that does not have to purchase all stock, so relatively cheaper. All right, but the problem is that, all right, you know, you're going to have increased. Major problem is the tracking errors, right? Because you randomly pick up the sample, or even using the representative, even though you use a cell weight, but again, you put that sample together, you may not have exactly equal to the same pattern of your underlying index portfolio. So we have some tracking error involved. Alternative way to do that one is, I'm not going to use sample, I'm not going to replication. How do I supposed to? Well, one way to do is using a factor model, like from our friends 3-factor or 5-factor model. So each factor is like a benchmark. Then you calculate the beta or sensitivity to that factor, and then you form a portfolio. And these factor portfolio, since the weight is based on the beta from that regression, so actually it catch out this covariance. So it count the covariance, and the covariance is correlation. So one strength of this we call modeling optimization process is that you can construct a well diversified portfolio using those covariance. So it is more technically difficulty, but has some strengths. But this approach may not exactly track index. Okay. So there's maybe some model misspecification. So you have so-called modeling errors involved, and also that in the model there's a lot of assumption there. You're assuming that each factor portfolio will be uncorrelated, which is not true. So anyway, this is a statistical or modeling error. So none of it then is perfect. So what do we do? Let's try to mix that. All right. So fully replicate large stocks largest stock in the index, and then using the stratified sampling or the optimization for the rest. So this is most of the time we do that is for large cap portfolio. We can easily replicate that because it's liquid, it's a small number, and the rest of those stocks, the medium size, small size, or other type of stocks or equity, we can use the stratified sampling and modeling optimization to achieve our goal.